Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful as you pass. Move along, move along.
Hello and welcome. I'm Brad Coogan, Editorial Director of MetalForming magazine at PMA, and on behalf of Senior Editor Lou Kren and our entire team here, welcome to another episode of our continuing MetalForming Live series of webcast panel discussions where we're covering a variety of topics of interest to metal forming and fabricating companies. So today we're bringing you a MetalForming Live on the Shop Floor program. So we'll be talking with two metal forming companies today, specifically about their strategies and investments in automation technology. So first up, we'll talk with automotive stamper Clover Tool Manufacturing about its use of transfer automation and specifically about a new pending installation of a 1,650-ton transfer press. Then we'll hear from metal fabricator Nelson Steel Products about its aggressive approach to automating its sheet metal fabricating operations, including welding, press brake bending, and laser cutting. So we'll get right to it. As always, I'm joined today at PMA headquarters by Lou and our distinguished panel of experts. Before we meet everyone on the panel, I want to say a special thank you to all of you joining us online today. I invite you to please participate in our discussion today using that Zoom interface in the Q&A panel. Please ask questions of our panelists as you come up with them. It is intended to be a very interactive event, and we want your participation. And of course, I want to thank our sponsors of today's program, Stamtec and Principal Financial Group, whose generous support allows MetalForming magazine and PMA to provide educational events such as this one. So, all right, let's go ahead and meet our panel. We'll start to my right here.
Yeah, my name is Paul Sturrett. I'm with Linear Automation.
I'm Corey Chamberlain. I'm with TSIM Solutions.
Jacob Fogarty with Mazak Optonics.
Ross Risinger with Nelson Steel Products.
Lou Kren, Senior Editor with MetalForming magazine. George?
George from Clover Tool.
Awesome. Thanks, George. Thanks, everybody, for being here today. Really appreciate your participation. We're going to have a great conversation, right? So to kick the conversation off today, we're going to bring in George Zenny from Clover Tool. He's going to give us a little background on the company, and then he was kind enough to provide a really nice narrated video tour of his facility. So George, welcome, and tell us a little bit about the background of Clover Tool before we show your video.
Sure. Clover was founded in 1979. I'm the second generation. We have two facilities that has over 210,000 square feet of manufacturing space. We provide tool and die, metal stamping, and value-add sub-assembly work. And our focus has been on automation. And the video pretty much will give you an idea of what the facility actually does.
Welcome to Clover Tool Plant Tour. Our facility in Concord is 176,000 square feet that houses under one roof a tool and die shop, two metal stamping areas, and a robotic spot welding area. The production facility is divided into an east press shop and a west press shop. The east press shop has presses ranging from 200 ton to 800 ton. This year we're installing a 600 ton Komatsu line and a 1,650 ton Eagle press line. All the presses can run progressive. The feed lines on each press is from the same manufacturer, which enables their Clover maintenance team to only maintain inventory of critical parts without having multiple manufacturing products. The last press on the line is an 800-ton PTC press, which handles progressive dies, transfer dies, and blank fed transfer dies. We can see a sample of coil fed here, and the second one is an example of a blank fed transfer. This is a stainless steel heat shield with 2 layers of stainless and a layer of insulation. Moving down the hallway from the east press shop to the west press shop, we have which is our original production area before expansion. Here we have presses ranging from 300 to 800 ton with all the capabilities of running coil-fed progressive dies. All the presses within the plant have a bolster 36 inches above the floor, which means all our dies have to be handled with a forklift, both putting in and out of the press. Our new 1650-ton press will be a floor-based bolster, which allows us to use 2 bolster plates rolling in and out, allowing for less handling and faster changeovers. That will be talked about a little later. Now we're traveling back towards the East Press shop from the East Tool Room, and you can see all the fixtures that we have for all our dies. The tool room is 2 tool rooms in one supporting the west side and one supporting the east side production facility. Here we do our maintenance of all our dies, continuous improvement, and engineering changes. The weld shop is in the middle of installing new production lines. So as you can see here in the first section, this particular line runs welding and induction heat treating. The rest is all traditional robotic lines, including this flex fast line that runs 3 million parts a year through one line. The construction, on the other hand, started in mid-2023 with the demolition of the existing footprint. The roof has been raised to 44 feet in order to house the new press line, the underground conveyor system, and a 30-ton overhead crane. This involves digging 18 feet into the ground, taking out 2,100 tons of soil, adding 320,000 pounds of steel, 48 tons of reinforcement, and 823 cubic meters of concrete, and 700 tons of granular under one roof. We expect the completion by the end of July and hopefully operational by August 1st. Thank you.
Good, thank you, George, for providing that video. Appreciate that. So Paul, the transfer system that George will be putting in on that 1,650 ton, that's running in your facility now, right?
It is currently on our floor running, yes.
Okay, so the schedule is for July?
Schedule is for July for installation, correct.
Excellent. Okay.
Yeah.
All right, and so I know you shot some video of it running in your facility. You've got a small, short PowerPoint to talk through, and we're going to see a video of the transfer system running.
Okay, perfect. Get the PowerPoint. This is actually a rendering of the layout itself with the press in the background. The press is an Eagle press. The coil feeder is from a company called Mecon that will be coming in behind our D-stacker. It's got rolling bolsters with parking posts, as you can see. And so the whole idea is to, set up the next die with the end of arm tooling and everything and roll it in for the quickest for die change. The coil feeder, also the D-stacker, moves out of the way while the coil feeder moves in. We've done a number of these type of operations in the last little while, and they give you the best flexibility. So if you've got a customer that's running coil fed, and then the next takeover work is a D-stacker, you've got a flexible cell that can run both. So this is a look at a sister press on an Eagle of 240 by 96. We'll go up to 30 strokes per minute, 28 inch of stroke, and 2 rolling bolsters, 80 inches of pitch in the transfer, and 36 inches of clamp on both sides, and 24 inches of total lift on the lift actuators. Maximum blank in this particular system will be a 24 by 60 inch maximum blank. So can you get to the next slide there? Oh, there we go. So this is a video, what we do, because we can't bring the press into our shop. We set it up on the floor with test fixtures. We use, you'll see coming up in the video, I-beams, black I-beams that are simulate the press. Actually, you'll see a window mount transfer in the background there also, which is interesting because we're going to talk about the 2 different types of mounting. Here's the D-stack head. What's missing is the boom. The tooling with suction cups will be picking up the blanks and running them into the transfer. And so Clover is going to blank offline at a different press. The stacks are going to be loaded into these stack carts with a jib crane. And then they've got magnetic. You can see those boxes on the pallets. Those are for building up a buffer zone, and they hold a number of parts while we're changing the stacks. So you never have to shut the press down. So you can see shuttle goes into the transfer. So when the coil feed is running, the coil feed company has a conveyor that goes over that shuttle down below and protects it and our head parks up and out of the way. There's the actual transfer itself. You can see at the end there's a jack screw where you lift the system up and out of the way during die change. Here it is running 3-axis transfer. We're driving it in and out utilizing belt and pulley mechanism, up and down using ball screw mechanism. And the pitch actuator is belt and pulley also. Something that we've run for many, many years. Very trusted and true actuators. So the finger tooling is gonna end up on the inside face of these rails. The pneumatics and electronics are all set up, ready to plug in. You can see a good look at the inside face there. And Clover is gonna be using tooling plates that 2 or 3 fingers per plate that go on inside face of the actual transfer rail. That's a good look at it in the shop. So here's a look at the one thing that Clover originally started looking at was a through the window style transfer. And we build both size style systems, as you can see in the photograph here. And so there are a number of pluses or minuses versus the window mount versus the front and rear mount. But one of the big driving factors is overall cost. I talked to the press company, in this case Eagle, and how much less it was to build the press without the larger window. And in their cost, it was about $140,000 less to build a smaller window on the press. And then there's the fact that you need through the window system. You can't put the coil feed system right up against the window, so you have a long tail out, and so you need additional automation to move the tail out forward, like a pinch roller type system. That can add up also about another $100,000. So you're talking of maybe $250,000 in difference in the overall cost of the unit before it even versus the window mount system. So Linear started out, everything we did went through the window of a press when we were a startup back in '94, which is now 30 years ago. The front and rear mount transfers were introduced in '98. We had a series of presses to run truck frame components, and they had no windows whatsoever. So we came up with a front and rear mount transfer, and we were cross feeding them. There's 5 large presses with no windows. That's when the front and rear mount started. Today, our sales are roughly about half and half now between the front and rear mounts and through the windows. The tier 2, our majority of them are front and rear mount transfers for a number of reasons that we're going to talk about coming up here. So the advantages of a window mount, one of the big advantages is that you can put sound doors on the press. You have a better visibility to see the parts because you don't have those heads in the way. It's some of the big advantages of running, when you can run certain blanks through the window, you can march them through the window of the press, whereas a front and rear mount, you'd have to extend fingers back to get those parts in the window, and same with on the exit end. The disadvantage of a window mount, it requires more room at the exit end and the front end of the press. And there's a number of other disadvantages, longer conveyors. And like I said, the other big disadvantage of a window mount is we have to make a much larger bar profile than we do on a front and rear mount. For instance, on a 240, we'd probably be about a 10 by 10 bar, where the Clover bar is a 6 by 6 bar, because we're holding it at multiple points. With it through the window, because you're suspending a bar, you've got like a skipping rope effect. So you have to make a much larger bar. So that's one of the other advantages. The advantages of the front and rear mount, mounts on any style press, like I said, even without windows, it can run multi-directional. So we have some front and rear mounts that will run components left to right, right to left, but also the system spreads out and runs truck rails front to back. So a true multi-directional. Only happened 3 times for us where we've had these, but it is a huge advantage. You've also got independent head control on a front and rear mount. I've got some video coming up just showing the different modes of operation. You can run crossbar, you can run a single head. So the flexibility on the front and rear mount is substantial. When it comes to takeover work, which is really important for tier 2 operators, it's very easy to adapt somebody else's bars and fingers from somebody else's press onto a front and rear mount. You can do it on a window mount also, but it's a much easier situation on a front and rear mount transfer. Disadvantages, requires more room around the press. So we have had 3 customers actually build like a doghouse around the press and put sound doors on, but it's a more complex operation than, and you also have to have longer rolling bolster tracks because we have to clear it past the transfer system on a front and rear. So this is, I talked about the tail out. Here's some diagrams just to kind of show what I'm talking about there. So you can see on the window system, the straightener, the feeder is can't get right up against the press. And I've seen, I mean, on window mount systems, I've seen them throw out 10 to 12 feet of tail out because they didn't have a pinch roller. So either if you've got it, you've got to have a pinch, some type of automation to advance the tail out. So big advantage to a front and rear on this. So this is a video of different motion profiles that you can run on a front and rear mount. And some of them are pretty funky. You'll see coming up here. So the first one is a standard tri-axis motion. This is kind of what Clover's machines are going to look like running. This particular one's got some rotation. It's a 2-out die. That's standard tri-axis. The next motion is running in Asia, actually, and they run everything what they call crossbar. So you'll notice there's no grip motion in this video. They're coming across with suction cups. We call it crossbar transfer. Customers that have Class A parts that they don't want to have grippers touching, or they want to get them with suction cups. This is running a part on one side only. It's a 2-sided transfer, but the one side's transferring the part, and the other one's just acting like a catcher's mitt to get scrap from. This shows the flexibility of these front and rear mount style transfers. The next one is a Class A part for sure, and the transfer is now, instead of tri-axis mode, it is running a pick and place motion coming across the part, which is seen by consumers. It's the outer portion of a blower motor in a furnace, and you can see the motion in this one also. This is called pick up. So the front rear mount can operate in all different motions. This is again back to crossbar motion. So this one's where you've actually got a crossbar motion running through the press, an entirely different motion than the tri-axis. So the transfer is capable of either or. Now we talked about takeover work, one of the big advantages of a front and rear mount transfer. And here's a couple of real life examples of takeover work that were like done in like 8 hours after receiving the dies. These guys were up and running with the, so here's one actually right here in Cleveland that it came from a different press, a different transfer, but we're able to adapt. And for a tier 2 stamper, this is really magic that they can run somebody else's bars and fingers on our front and rear mount style transfer. Here's one that's running 36 strokes a minute, and you can see it's an older mechanical transfer that they literally, this went from 11, 12 SPM up to 36, running on a front and rear mount transfer. And you can see it's a real easy adaptation with an L bracket, but running transfer bars from a different transfer altogether. And the last one is also a competitor's transfer bars running in the inside face of our bars. So that just gives you a look at the flexibility for takeover work, which is really important for companies like Clover. Okay.
Good deal.
Yeah.
Thank you, Paul.
Yeah.
And so Clover, George, we were talking earlier, you expect this new press when it goes in July to take on some takeover work. Is that right?
Yeah, it was, we started talking to our customers and we realized that there was, I would call it a shortage of this size press and transfer system in the industry, specifically in Southern Ontario. So we had a lot of conversations with a lot of our customers, and they've made some commitments, and we went ahead and purchased this based on what was out there. And we automated as much as possible, including everything with that linear offered, plus Eagle, plus conveyor system, underground scrap conveyor, just because of the shortages of people and skill sets out there. We literally have our own internal school of training for our staff to upgrade people's skill sets.
You showed the last part of the video showed the pit being worked on, right? Can you
Right.
share a little bit of detail from your recollection of what's involved in that? It's obviously a massive pit.
Oh yeah, I can tell you some stats. There was probably 320,000 pounds of steel, 48 tons of reinforcement, 823 cubic meters of concrete, 2,100 tons of soil removed, which is about 130 dump trucks, and 733 tons of granular put in there. So there's quite a bit. As you can see, that's where the press is sitting, and that right out to the back, where the back wall is, that's where the scrap conveyor system is going to be coming out. All of that is about 15 feet below floor, and I think the press will be 32 feet above floor level. I think the press alone is close to 1 million pounds. So a lot of engineering behind that. And we had to, of course, we didn't have the building height, so we had to get permits and knock down that whole section of the building and raise it to 44 feet so we can put on not only the press, 30-ton crane to run over it to help with the process of moving coils around quicker rather than the old way of forklift, which is pretty much the rest of our plant. And the rest of our plant is all scrap conveyors at the end of every press. So involves forklifts taking scrap away and dumping it and putting in containers. So we have eliminated all of that and tried to literally automate everything that we possibly can.
That was my next question: is do you have underground scrap in the other parts of the plant, but you don't?
No, this is the only one, but we've designed it so that we can actually put a second press beside that, over top that scrap conveyor, so we can utilize it better.
Press. Paul's ears perked up now.
Oh, I know, it's, I always perk up on the second.
Well, it's natural, right? And if you've got a piece of equipment, whether it's, a press or a wire DM machine or anything, once you have one, you have to get a second one to back up the first one. Because if one falls apart, the next one's got to take up the load.
And your next biggest press, I forgot what you said.
800 ton is the next largest that we have right now, but it's bed size is 72 by 204. So yeah, it's and again, whenever you get a press, whether it's 240, 202, 204, whatever, the next job you get, it won't fit in that press because it's too small. Always happens. Always.
So I know Corey is here from TSIM, which specializes in when companies like this make these big investments, you want to optimize the runtime, right? You want to optimize OEE, you want to run as fast as you possibly can, reasonably, right? So we talked about that too. You can try to go too fast, but so talk a little bit about your work with George on optimizing.
Yeah, absolutely. Yeah. And when companies like Clover and George make an investment like that, I mean, obviously it's a big investment, not just the press, but all the prep work that you have to do, the construction, everything that goes along with it. So you want to make sure you're getting the most return out of your investment. And we talk about customers, whether it's a brand new press that you haven't or one you've been running for decades, as a lot of the stampers in the United States have been. The most important thing you can do is utilize your equipment as efficiently as possible. And that's one of the things that kind of all starts there is understanding how do you know what that is? Like we were talking before, all of us when we were chatting up here on the panel about that is your OEE or what your actually equipment efficiency is. It's an interesting conversation to have with customers and say, how do you guys measure that? Because a lot of people, quite frankly, they'll say, well, it's because this is what we quoted the job at, so we base it on that. And I said, well, what if the part's capable of going faster than that? Oh yeah, but we know we've got to have something to start with. And it's kind of astonishing to me a little bit nowadays with as much data as there is out there in this world and the way that people utilize data now, that we're not doing a little bit more of that in the production plant. So companies like Clover with George on their PTC 800-ton press, we've had the opportunity to work with him and his team a little bit on a project that they're doing in there. And just to give an example of kind of what we do as a company and where we can help with stampers is they had a part that they're currently running at about 15 strokes a minute. And he said, hey, I want to see if there's opportunity in it. Is there anything we can do to make it more efficient? So we took a look at it. and checked the job out and really dug into it. And with the technologies that are available today with simulation and things like that, you can really ask those what if questions and dig deep with people. And it's been a lot of fun with his team there. So we started looking at the project, and they really did a good job with their initial recipe to get it as fast as they possibly could out of the gate. But the problem really with that one is there's some tooling obstructions that they had in the tooling design. And a lot of times you'll look at that and say, oh yeah, that's the bottleneck, and that's a problem, you know. And we always talk about bottlenecks, you know, that's one of the things that comes up a lot with us. And what you can find though is you can say, okay, now with the technology, I can ask, what if I remove that bottleneck? How much faster can I go? And in the case of the project that we're looking at with Clover there, they were able to go from 15 to 18 strokes a minute by altering the die design. It might be $3,000 to $5,000 to alter the die design, but you're getting a 20% increase in production. That's pretty significant. So those types of things are really where we like to focus. So we always kind of talk about, there's two ways you look at bottlenecks. It's the equipment and then it's the tooling. So you have your press and transfer, all the stuff that they're investing in right now. But when you get into looking at it, the other counterpart of that is what is the tool capable of? So like with bottlenecks with equipment, it's relatively easy to say, okay, this is what the equipment can run. Like Paul, you guys have software where you'll check and see what your
so we get when we're starting a project, we get the parts, the heaviest parts, the biggest pitch, grip, and lift. We focus on that part and build. We have dry sizing software that we build the transfers to, because we don't need to be the bottleneck. We don't want to be the bottleneck, and we build the entire. And yet we don't want to overkill it either and price us with. So we try to build around the heaviest, ugliest profile, and we build the system around that, and that's with the drive sizing software we've had for about 20 years.
Yeah.
And we've developed over the years with each of our, like we deal with Siemens, Bosch, Allen Bradley, or Mitsubishi.
Yeah.
So we have a program for each of the four projects. And we that's how we quote right out of the gate.
Yeah.
To make sure that we're not the bottleneck.
And when you guys do that too, I mean, you know that your equipment can run that fast, but the reality and what we find, and this is kind of where we get involved a little bit more with companies, is that even though the equipment can do it, it doesn't mean the tool can. And that could be the tool or just the nature of the panel as well.
Yeah.
You know, so you run into other real world factors that come in. Just if the transfer can run 30 strokes a minute, you know that every job in the plant's not running at 30 strokes a minute. And I'm sure there's a lot of CFOs out there who have said, hey, we said this press could go 25 strokes a minute. Why are all our jobs running at 15, you know? And that's just a reality of things. So we really like to talk though and dig in on the optimization. So it really starts with understanding the equipment, knowing what its limitations are. We find with a lot of older equipment, when you don't have the luxury of having a new press like what George has going in there, we find that what you'll see is that when maintenance is done on equipment over the years, a lot of it's not calibrated properly again. It creates a lot of issues with presses and things like that. So we always like to go in and say, let's start by getting the right information so we know your real capabilities.
Sure.
So the big push with us is we say, let's verify all these key things. Slide timing, for example. A lot of people are really shocked when I say, hey, you know, your encoder's off on your press by 10 or 15 degrees. They're like, well, what are you talking about? I said, yeah, your bottom dead center is not at 180, it's at 165. And they're shocked by that. And they're like, well, we got to get that fixed. I'm like, don't fix it, because now all your transfer programs will be wrong, you know? So you kind of chase the ball a little bit there. But once you know what it can actually do, that's really the whole key. And when we say OEE and we talk about those kinds of things, we're saying, know what you can really do for each job. And the only way to do that, honestly, and not plugging shamelessly or anything like that, is, but you got to have the right tools to do it. You got to have the software so you can do the analysis of it. You got to know how to push the equipment, have the techniques and methods to do that, so that you can really dig in and know what those things are. So then your OEE will actually be reflective of real OEE, not a quoted number.
Yeah.
So.
And that 20% you quoted with George's going from 15 to 18, that's pretty common.
Pretty common.
Yeah. I would say too, even, you know, we always hesitate to throw out big numbers and stuff like that, but we did a 10 tool study, or 10 customer study, 10 tools each for each customer. And we asked them to submit back information about what results they got by going through and doing optimization on existing press lines. And the average on that one was actually 40% is what they increased. Wow. So that's a huge number. And I would never tell everybody, hey, expect you can get 40%. But 20 is a very conservative. I think it'd be hard to find a press line out there that's running right now, if they haven't already utilized some optimization software to do that, that you couldn't see that kind of an increase.
So then we talked a little bit about, before we went live, about what this does. You know, you're moving the bottleneck, I guess, right? You're going faster. You got parts coming off faster. How are we going to get all those parts? I know, George, you said you're not at this point looking at end of line automation, but you guys can talk maybe a little about, you've called end of line like the next frontier, the final frontier.
Yeah, the final frontier, yes, I couldn't remember that last time. I don't know where I heard that from. But the final frontier is auto racking. George, we've talked to your team about potentially auto racking. It's something you don't need to do right at the, but do you have trouble finding skill or labor, not skilled labor, but labor to rack parts at the end of the presses?
Yeah, it's the most mundane, boring job, and if you're doing changeover twice in a shift, it's different. But if you're long runs, you've got to switch people around during their shifts because they just can't keep doing that same repetitive motion, especially if the parts are heavy. In this particular case, when we started off this journey, we had a set number of parts, and we showed you those parts at the time. But with the OEMs, they've made engineering changes, and some parts didn't fit in that press, some parts were canceled. So when we actually go into production, it'll be a whole new set of parts, and including takeover parts of existing from existing stampers. So once we get that in place, then we'll have to reevaluate. But you're right. It may be a point that we'll have to look at some automation at the end there.
That's not uncommon. We see that being the bottleneck a lot of times. And if you can get to the point where it's just a person at the end of the line being bottlenecked, that's a great thing. Because those often are positions that you can rehire for and train, and you can do the ROI on it pretty simply.
Yeah.
But it comes down to knowing the data and really understanding what the real capabilities of a tool is. If you can go from 16 to 20 and it's going to cost you one more guy packing at the end of the line, it's probably a worthwhile investment.
And the other thing is that if you need two people at the end of the line, and then when you finish running that production run, what do you do with those two people if you don't need them at the end of the line? You got to move them to somewhere else. And so that's another challenge.
What else comes with, though, increasing the production speed 20, 30, 40% of equipment maintenance or?
Yeah, it's a great question. A lot of people. Yeah, there's that. It brings its own problems, right? One bottleneck becomes the next, and that's the natural progression of things. Because as soon as you start speeding things up, you're going to find another problem here. It could be the tooling. Yeah, it could be part storage, logistics, moving the parts in and out. But what we're finding though too is surprisingly, a lot of our customers, they're not just looking to be faster. They want to have more consistent uptime that helps your OEE too. But they also want to make sure that they're not beating the daylights out of their equipment. When you're running your transfer at 90 or 100% of capability all the time, yes, they can do that, but you're going to have a lot more wear and tear on them, a lot more maintenance and more energy consumption. So it really depends on each company's unique and what they're going after when they say, hey, we want to optimize our stuff. We really try to dig in and understand what is your goal, what do you want to accomplish? And sometimes it's a little bit of everything, but more often than not, they want smoother curves because they're beating their equipment down pretty bad, and they'd like to get an increase in production if they can handle it. And it's a great problem to have if you need another guy, like you say.
So when you walk through a shop like Clover Tool or another, they can't optimize everything all at once, or every press, every job at once. So what's the ideal job? How do they identify?
Yeah, that's a great question.
Fruit, if you want.
Yep. We actually talk with our customers a lot about that. So we have some resources and stuff like that. We'd be happy to share with anybody who's interested. But we kind of break it down. We say the simple thing is we call it LSSO. List out all the jobs that run on the press line, sort them out based on what is the limiting factor in them. Okay. Select the lowest hanging fruit that you have and then optimize those ones. So you can do that in a really short amount of time by just going through and we have some criteria that we break it down. We say is a die limitation. Sometimes you have forming speed as an issue, or you might have some issues with a panel sticking in the upper. Those things, anytime it's possible, we say, fix the die problem, before you call us in there. If you know you have an issue, take care of that first. You can't always do that. And sometimes you don't have the luxury of an internal tool room and things like that can handle those things. So there's a lot you can actually do just with a recipe though. So, if you're having problems setting down a panel and it's disruptive once you go over a certain SPM, you can lock in that speed in that one portion of the transfer cycle and re-optimize the rest of the cycle and still maintain a good rate. So lots of options with that.
What about from your side? How can you help ensure this project with Clover is pretty unusual? I can't imagine you do too many 600, 1600 ton. Press lines.
A trend is these are more and more common. The large bed. George, this is the first real big bed press that you've had, right?
That's correct. Yeah.
Yeah, I mean, your other one, we've got a transfer on a 144 and a 180, I think,
Yep.
at your place.
That's right.
This is a huge project for a large bed press, but it is becoming a trend. If you look at our floor right now, we've got one for a 368-inch bed, so it's an extra. We've got one for a 240 right next to George's. A lot of them are large bed presses.
Yeah.
When I started 25 years ago, a 180-inch bed press was massive. And today it's really, you know, the large bed presses are definitely a trend.
So giant investments. So, you know,
Giant
making sure
investments.
that they're successful on time, you know, as close to on time as possible, on budget.
Yeah.
What's some of the advice that you can offer, you know, to companies like?
Well,
Clover
like
to-
during the process, I find that if you don't get all the vendors involved in a project like Clover, and you don't talk to the press guys and don't involve the coil feed guys, the simulation guys, everybody, all vendor meetings have been, in my opinion, over the years, because I've seen many projects go sideways that didn't, the groups weren't talking to each other. That is the key to success. And in Clover's case, we've got everybody involved in all vendor meetings all the time with the dice, because it's a lot of moving parts, right? And including the press company. So I think that's, if I had to give really good advice on how things don't get off track, is all vendor meetings, making sure everybody. And I've always been, we've always been a big fan of T-Sim. If you're not using simulation software for any transfer dies at this point, I mean, we've it's a very low investment for what you bank for what you get. Huge investment.
And I would echo what he's saying too. I mean, it really is a big deal to have the upfront planning. You know, get people in early in the game. And that's a tough thing to do when everybody's quoting against everybody and all these kinds of things. But Paul, I know, is the same mindset as me in this, is that when you work with the right people, the value that you get out of it is significant. So it's unfortunate that sometimes it always comes down to price. But when you have a team that's really willing to invest into your company too, which is what a lot of us here love to do, it can be great when you start right early on in the planning, like you're talking about, get involved early and really understand what the customer's needs are and make sure that we're meeting. So.
Yeah.
Does that all vendor meeting, which I've never heard that before, but it's probably.
Today we do them online more than
Is that driven by George in this case, or
it's
is that
usually
the
like our
press
project manager and his project manager will get together and try to create an all vendor meeting. I mean, they've been going on forever, but it's amazing how many companies don't.
Really?
Yeah,
And,
I was
you
gonna
know,
say it's the exception more than the rule.
Is that right?
Yeah. When you've got a new press, though, new coil feed, new everything, it should be a norm. And it should be driven from project management from Clover and from us.
Yeah.
We always try to promote it, and I know that that's how we have successful projects, right? So at the end of the day, if it, you know, I mean, this is the third system that Clover has bought from us. We want them to buy a fourth and a fifth, right? It's you get a black eye in one project and that's it for you, right?
Sure.
So
No black eyes.
yeah, no black eyes.
Anything else you want to say, trends in transfer automation, or what do you see going on in end of line? Are you seeing more and more customers at least?
We're doing more end of line
Yeah.
quoting and also doing actual end of lines. We've done some in Georgia just recently, some in Auburn Hills. It's definitely becoming, and especially at the OEMs where, you know, there's big issues there with people racking parts and they want to go slowly because they don't want to. So that's a natural for auto racking down the road. In high per capita incomes, like where Clover is located, it's not exactly a low per capita income area. It's hard to hire people to catch parts. We have another customer in the same region that just can't hire people to catch parts. So he's doing it out of necessity. And it's a big trend. As far as overall trends, we've kind of seen a lot of like one-sided transfers lately. It's kind of an interesting.
Really?
Yeah, our shop has 3 of them on the go right now. A lot of gap frame line. You know, instead of buying a big straight side, they'll get away with buying multiple, and we're doing robotic press to press. So there are a lot of interesting trends in the anything else that you're seeing out there?
No, I was gonna say, did you guys also do some solutions where you to utilize smaller bed size presses, where you'd pass the part down one side and then pass it across?
Over
right
across
the
and
other
yeah,
side?
doubling the
Yeah, I think
bed
we
size
would
of the
do
press.
those.
So
I
and
think that's a great utilization of something like, and you were talking earlier about front and rear versus through the window. That's a great advantage to a front and rear system, right?
Absolutely.
You have the ability to do that.
to
So
do a
different
horseshoe
parts.
on the press.
Yep.
Yeah.
And there's other projects where we're marching the part along, but the press isn't quite long enough, and these dies, they had to bunch them up at the end. So as we're pitching forward, we're moving back on the bar just to
Oh,
make sure
really?
that press, yeah,
Pitch.
that's
I've
kind
never
of
seen
a,
that.
yeah, that's, I mean, it's either that or get a new press that's longer bed, right? So,
That's cool.
the automation that's available today is amazing. We've got part ejectors that are actual servo motors we put in the upper dies, ejecting parts like seat tracks and various things. So it's amazing with the general automation around a stamping cell, how many options there are.
Yeah.
And our customers love utilizing, like quite often these ideas aren't ours. They're
Right.
customers, can your system do this or that? Like you saw that one-sided system on there and it was 100% the customer's idea. And we're like, yeah, I can do that. And he could run on one part and just use the upper, and he goes, I thought I could. And so these are just driven from the flexibility in a all servo system.
So we see a lot more customers too, doing a lot more on the bar rotations and things like that.
Yeah.
Where they're trying to get a little bit more flexibility within the press line. That creates all its own challenges as well. But I think that's one of the things I've noticed a lot as of lately is that as the more and more of the engineering is going overseas, not a knock at all, because they're fantastically talented people, but they don't necessarily have the same processing experience that a lot of the US based engineering companies had for decades and decades. So you're seeing a lot more of these types of inline automation that you're doing in the presses in order to compensate, because they couldn't come up with a process to make the part,
Sure.
in a more conventional way. So, but yeah, it's good.
In a big picture, the trend to bigger beds is not small, it's quite
Yeah,
large.
it's not gonna go the other way.
No,
Right?
no.
Very good.
So,
Thanks, guys. George, any final comments before we move on to our next case study?
No, the other thing that we always seem to forget to talk about was with transfer, your material consumption tends to be smaller per part because with a prog die, you have carriers and all that. So you actually save also on the material consumption, and you're more competitive on certain parts. So we tend to forget that part.
you're doing my
Paul,
job.
I'm doing your job, Paul.
That's awesome.
That's great.
George, thank you so much for sharing your story. You're gonna hang out with us for the rest of the event. So if anybody online has questions for George, please go ahead and throw them into the queue. But for now, I'm gonna turn it over to Lou and the folks from Nelson Steel to talk about their fabrication operations.
Okay, thanks, Brad. Thanks, guys. Same track, shop floor automation, but we're gonna shift gears just a bit, focus on automation for laser cutting. With Ross Redzinga, president of Nelson Steel Products, and Jacob Fogarty, automation specialist with Mazak Optronics. Nelson Steel Products, Holland, Michigan, is a single source for complete metal fabrication, including laser sheet and tube cutting, robotic welding, stamping and assembly and packaging. Recently, Nelson automated the loading and unloading of its laser cutting operations, which we featured in the December 2023 issue of MetalForming magazine. Ross, can you tell me a little more about Nelson Steel Products, including its automated welding and automated press brake bending?
Certainly, thanks, Lou. As we're a fourth generation family business founded in the 1940s. We have about 150,000 square feet manufacturing space. We run 2 shifts and have about 110 employees. And you mentioned the welding capabilities. We have 14 robotic weld cells, 22 robots in all. Some are small single head turntables, some are larger, like this video here, showing a large double head cell. That's welding a base for a floor scrubber. With a lot of, I forget how many welds are on there, but it's in the hundreds of different unique welds. And then in a minute, it'll jump over, I believe, to the next video that shows some longer welds on a different part on a similar cell. And so those cells right on rails can really utilize some large weldments. And some of our other cells, like I said, are smaller cells, small turntables, for different varieties of parts. There's the video of the large wood chipper infeed there. So that weldment has some really long welds. Some of the welds are over 4 foot long, where the customer wouldn't allow any starter stop points. They're all weave welds. The nozzles all had to be water cooled on there. We ran into issues with heat originally when we were working on that project. That customer actually went to 5 other shops before us trying to do that part robotically, because they were doing it all manually themselves. And all 5 of those shops failed before they came to us, and we were the first ones that were able to do it successfully. So that was a pretty fun project to work on. You can kind of see the length of the welds there. It shows the weave and the quality of the weld. Like I mentioned, no start or stop points allowed. So all has to be continuous welds. But we also get into a lot of automation on our press brakes. We've got eight press brakes in all, ranging from 60 ton to 350 ton. And in 2019, we put a robot on one of them. All of our press brakes are Cincinnati's. And we worked with an integrator out of Iowa on this project. And kind of designed it around about half a dozen different part families. And all of those part families had a variety of sizes of the parts, but utilized similar bends in them. So this one in the video here is a channel that we do frequently, and in a variety of sizes. This is kind of a medium-sized channel, but as you can see, that end of arm tool was designed quite longer to be able to fit some of the longer ones, but can obviously turn on and off the different suction cups for the different length channels that we run. So that was a really good integration, and timing was great. So we finished the install literally the week before COVID lockdowns went into place. And we were actually running that cell lights out during COVID, forming up parts for hand wash stations. So sometimes timing is everything. But yeah, like I mentioned, there are half a dozen different part families on there that we do. It's got all auto end of arm tool changing to be able to go between the different part families, stacking, unstacking for multiple stacks, and then different part flipping stations and stuff there as it's rotating the part. And then the press actually has custom back gauges on it with prox sensors that are reading back to the robot so that the robot knows when it's against the back gauges. Yeah, and then getting back over to the laser side of things. We've been laser cutting since the mid-90s. We got into lasers, and like the guys were talking earlier, whenever you buy a piece of equipment, you buy one, and soon you're buying a second one. So we had two very traditional style Mazaks, a 1,000 kilowatt and a 2,000 kilowatt single bed lasers back in the 90s. We've since gotten rid of those, upgraded to the higher kilowatts. We now have 4 sheet lasers. We've got a 4 kilowatt CO2, a 3 kilowatt fiber, and then 2 10 kilowatt fibers. All of those have automation systems that are loading and unloading the sheets, which I think we'll see here in the video. But yeah, as we get into the higher kilowatt lasers, the automation really becomes important. Just like Corey was talking about with machine uptime, with lasers, it's all about beam on time. So the more that we can keep that beam cutting the better. So there you can see in the video, the double pallet changers, both 10 kilowatts have double pallet beds. So while the automation is feeding the one bed, the other bed is already cutting during this whole sequence, and it's loading and unloading each sheet, loading with suction cups, unloading with forks. And then we like to unload onto those pallets there. We pull the pallets offline, and then pull all the parts out of the nest offline. We built a little buffer station, so if the laser gets ahead of the parts pullers, there's room for flexibility there. All of our automation that we have, whether it's welding, press brake, laser, everything is focused around flexibility. We serve a lot of variety of industries. There in the video, we can see the two of the automation lines on the lasers. The one on the right there is an FMS system from Mazak. That's got the 3 kilowatt fiber and the 4 kilowatt CO2 in it. The flow is very similar on both of those. On the left is a Remark system on the 10 kilowatt. And so that's the newer system. Then we have another Remark on our other 10 kilowatt as well. But really having those automation systems really helps focus on that beam on time, like we mentioned, allowing operators to focus on cutting, not having to get parts out of the way, getting those parts out of the way easily and offline, so that then other people can focus on pulling parts without interrupting the flow of the lasers.
So that you know, going back into the seventies with your grandfather and his brother owning the business, that's really where the focus on automation started. I know you brought turret presses in early, maybe if you want to say a word about that. And just kind of that family philosophy and company philosophy that led to what you have now in terms of the press brake welding and the laser cutting automation.
Yeah, so going back generations, like you mentioned, my grandfather, I've heard many stories from him repeatedly about walking into the McCormick Center. We were all talking about FabTech earlier. About the first time he walked in there, and everybody in the entire McCormick Center was flocking to Amada's booth to hear what this crazy noise was, and it was the first turret press they had ever seen. And it wasn't long after that he was buying one, and then not long after that buying another one. So our first one came in the late 70s. Back then, programming was on tape reels. Since they've been upgraded with new computer controls, but we're still running those. We do a lot of countersinking, tapping, embossing on the turrets, stuff that you can't do on the lasers, and then utilizing the lasers for stuff where they're better suited. But it's really that mentality of watching where the industry is going, where the technology is, what technology fits our business. Not all technology is going to fit, but really keeping an eye out there for what's out there, what's changing, and what's new, and not being afraid to jump in and invest in the new technology when it is a good fit.
Okay, and Jacob, if you could comment a bit on the technology in place for laser cutting automation at Nelson, and also you know, some other related technology related to part sorting and things like that. But what else can we expect to see as automation on laser cutting lines?
Yes, so the automation at Nelson Steel is you've got your basic load unload Remert systems, and you also have a load unload with a material storage as well, with multiple shelves. I think you got 10 different shelves that you can stack material on. So that's kind of where the industry's been for, I'd say, about the last 5, 10, 15 years. It's just the load unload and the material storage. Now we're getting to the point where part sorting is getting more and more important, because like you were mentioning, you have these stacks of materials that then you have to take to another station where you have someone manually unload those parts as well. Our goal, and we're investing in just 6-axis robotic technologies, because it's something like you guys are already familiar with. Using that with interchangeable tools to pick the parts off of the laser bed itself. And then that allows flexibility where, in addition, you can use the robot to pick the parts that are well suited for the robot, or if you have smaller tools or smaller parts and more complicated parts, you can still send those to the be manually picked by the labor. That's kind of where the technology going now. The main goal with the part sorting as well is keeping it as simple as possible. You don't want to spend, you know, an hour programming the robot to pick a new tool. So we've really worked on utilizing our own nesting software and integrating the robot sorting with that, so that now, you know, it's just an extra, you know, 5-minute step at the end of your nest production to set up where you want these parts and how it's going to be sorted, things like that. So that's where we're really focusing now at AZAC with our automation.
And that's getting really important with, we mentioned the different speeds of the bigger lasers. Just for example, on, I believe, 6 gauge on our 4 kilowatt CO2, we used to cut at 100 inches a minute with nitrogen. Now on the 10K, we're at over 600 inches a minute. And that's just the 10K nowadays. Mazak's got 20s and there's 30s coming.
Oh yeah.
So it's becoming critical to be able to move those parts down line.
Sure, all that material's going somewhere, so
Yes.
you have to be able to handle it. And so if we could back up just a little bit, Ross, the decision to bring in that automation for laser cutting, I know it was informed by the, you know, the higher laser speeds. Can you talk about maybe some other factors? Was it possibly, you know, workforce? Maybe not enough people to handle it, or did you more orders, or what else drove that decision?
Definitely. I mean, volume is a big aspect of it. Ergonomics are another one. It's nice to be able to get those parts into an area where you have the proper tools and equipment to be able to get them pulled Some of the parts that we pull might be out a 1/4 inch and they might be close to half a sheet of material, which gets pretty heavy. So we actually have areas with cranes with magnets that are pulling those parts out of the nest. And we just deal with a huge variety. We're cutting stuff from 24 gauge up to 5/8 thick.
Mhm.
So it's real important to be able to get that out to where you can handle it properly and efficiently, and you don't have operators that are trying to lean over a laser bed and have a table that they can get a little bit closer to.
And also, you know, because that laser cutting equipment that's supplying other processes within Nelson Steel, what did that lead to? Like the ability to bring stuff out faster through that laser cutting operation, through those operations? How did you have to deal with that down the line? Like what did you do on other processes?
Certainly bought more press brakes.
Yeah.
Every time you buy a new laser, you gotta buy at
Yeah.
least 2 or 3 press brakes.
Okay.
So that's been a change, but also, I mean, that's led to the automation on the press brake side as well, and as well as other automation that we're looking at down the road.
And I think the point is that this kind of automation doesn't take place in a vacuum.
No,
It's affected coming in, going out, a
no,
lot of other processes.
same as
So there's
with
a
the
whole lot.
stamping,
Yeah.
you guys were talking about, you find your next bottleneck. We eliminated our laser bottleneck and we found our next bottleneck. Yeah.
Is it a similar all vendor on board situation though, Jacob? Are you working with the robot integrators, for example, to?
Yes,
keep
so,
it-
Mazak, we're gonna be doing all the, integration. We don't wanna overload our customers with a bunch of different
Okay.
people to talk to, so everything comes through Mazak, and then we'll present and install and, maintain any solution that, we deliver to a customer.
Yeah, from a customer standpoint, that's where Mazak, I think, does a really great job. They're our single point of contact. And so they have automation systems they offer internally, but they also have partnered with companies like Bremer. And Mazak owns that relationship. They
Yes.
own the install, they own the maintenance. So when something goes down, we have one phone number to call.
Yeah, the last thing we wanna present is, you know, having you guys call in with a problem, you're like, oh, well, that's not our problem, we'll transfer you to the automation department,
Yeah.
or we'll transfer you to this company.
Sure.
you know?
Yeah, you really
We don't
eliminate
want
the
that.
finger pointing.
Yeah, no, we wanna own all,
Okay.
everything, yeah.
I'm glad we don't have that at all in our. Never finger
Yeah.
pointing.
Yeah.
I mean, we see more and more automation on the cutting side with the you know, the table, the material tables and the shelves and
Mhm.
part sorting. But, we always see at FedTech lots of press brake robotics shown, but when I'm touring fab shops, I don't see a lot of that. We're seeing more of it, but not a lot of it. So I'd be curious, Ross, from your perspective, the biggest challenge with adding robots to press
Yeah,
brakes?
so it's certainly part variability, I would say. With press brake forming, there's always variability, whether it's in the part, or the setup. And so trying to overcome that and compensate for that. You really have to have precise components coming in, and you have to be precise on your bending, to be able to do it successfully. And there's a big upfront cost. It's definitely easier to hire people if you could get those people, but as we all witness, you can't always get those people.
Right.
So to be able to take those monotonous jobs off of a person and put them on a robot, let your people focus on the short run jobs where they can do changeovers and everything else. It's really important.
Are you automating between the processes, then, between the cutting and the robot, so there's no, or are you moving?
Moving it manually.
Okay. That's
Currently.
some of that.
There's some, you really need that volume and the right set of parts for that.
You mentioned before two sensors in the back gauges, I think.
Yep, yeah, there's proc sensors on the back gauge that are telling the robot that it's against the back gauge. So you're not relying just on the position of the robot, which helps as well. It was a well-designed system. The company that we used for the integration had partnered with Cincinnati, and they're actually had produced a lot of Cincinnati's
Oh, okay.
cells as well.
So how many automated press brakes do you have?
We just have the one right now.
Thinking about looking at more, or?
Yeah, I think there's a lot of equipment I've always got my eyes on. I walk through Fab Tech like a kid in a candy shop. But I'd like to, I think some of the panel bending and folding machines are coming along with some really cool automation. So I'm really interested in some of that as well. We currently don't have any panel benders or folders, but I think that could take a load off of our press brakes as well.
All right, we can take questions from the audience, or did you have some other questions, Lou, for these two guys?
I think we're good. I think.
Okay, so one of the things, we talked about this before, when fabricators and stampers are integrating automation is the workforce issue, right? So it's a little bit different workforce required for an automated facility, highly automated facility than a manual labor. So I'm curious from George and from Ross, what you've done or are doing to meet those workforce challenges when it comes to programming, maintaining automation equipment. I know there's a big shortage of automation engineers. It seems like the automation engineers that graduate these days go to the companies supplying the automation. They're not, the fabricators and stampers have a hard time bringing on engineers that can handle automation. Maybe they don't need engineers, maybe just highly trained technicians is what they're looking for, but I still think there's a shortage of those too. So from George and Ross, I'm curious what you're finding as you automate more and more, how to handle those. Are you finding challenges in that? And if so, how you're handling them? But Ross, maybe if you want to track that first, then we'll go to George.
Sure. We, to be honest, haven't found too many challenges in that. Some of it comes with your automation partners. Partners like Mazak, like I said, they take ownership of the automation on that side of things. And so the training that they offer has been great. We, as far as being able to operate and run their systems, we really haven't ran into too many issues from that. In general on robots, in the other areas, we've found that a lot of, especially the younger workforce, is eager to learn. If you put the opportunity in front of them and are willing to help train and give them that opportunity, we've found that a lot of the time they're eager to learn that, and they'd rather push the buttons and program than have to load parts themselves.
Yeah. So how do you identify those people? Can you actively walk around the shop and say, are you interested in?
Yeah, I mean, we've got a good pulse on knowing. We're a small enough company that we know everybody we've got pretty well, and have a pretty good pulse on who's eager, who's working hard and looking for. You can tell the guys that are looking for the overtime are usually the ones that are also eager to learn.
Okay.
So the guys that are working Saturday morning are often the ones that are getting the opportunity as well.
Okay. Do you guys find anything when you're talking to customers about what they have to do differently?
I actually had a funny story, a customer in Toronto, not far from where George is. He said, I watch people walk behind our building, and if they're walking with a purpose, I'll go chat with them. And he said, he pointed 2 or 3 guys out that he said, if they're just dawdling along, I'm not interested. And if they're walking with a purpose, that's how hard it is to get.
Awesome.
Yeah, that's for catching parts. And yeah, it is, walk with a purpose. And he literally stands there and watches them. And he's snagged 3 or 4. So that's kind of a funny story.
Very cool.
The other thing that we were talking about beforehand too is it's kind of a lost art a little bit, but we used to always have apprenticeship programs and stuff, and we've seen a lot of coupling where you'll see an older, more experienced person in the facility and maybe taking in an intern or a young college graduate. And like you were saying, a lot of these young guys, they'll adapt to the technology much quicker. And we're a software company, so when we go in and present to people, one of the rebuffs we get a lot is, I just don't have anybody who can do that. That's okay. Go get an engineer out of your nearest college here and send them with one of your guys that really knows tooling and understands it. We can make you a dynamic duo that's better than Batman and Robin. So right. That's something that I think we need to see more of that though too, because we got to pass that knowledge down. So
we have a really good community college that has a co-op program that we try to bring on. We bring on numerous co-ops throughout the term, and most of our senior managers today came from that co-op program at one point. But so not every town has a good college area, but that's where we've found a lot of talent at the college level. So,
George, any comments from your perspective?
Oh, a lot of similarities there. Yeah, we do have challenges being a tier 2 supplier. We train internally, as I mentioned before. We have a lot of programs where we pick people within the organization that we feel that number one, they're willing. Number two, we hire for longevity. We don't hire for 6 months, a year. It's long term. And the problem is, as a tier two, we train a lot of people, and then they get plucked by the OEMs or the tier ones. So we're in a constant training mode, as you could say, all the time. And it is frustrating, but it's part of our culture, part of our what we do, and we want to promote as much as the skill trades as we can, because there is a shortage. And yeah, it's pretty much in every area of our business that we're constantly training.
Okay. Question from our online audience. Ross, you talked about variability issues and overcoming those. Is there technology in the automation? And that's the same question maybe for Corey. Is there automation technology that's been developed recently that helps deal with that variability? You mentioned the sensors and the. But I don't know if that's new, but
I'm sure there's other cells, and integrators can produce cells that have vision systems. They can measure bend angles in process.
right.
Press brakes also have some systems available where they can measure the bend angle in process. And that's not something we currently utilize. We try to just make sure we have accurate parts going in. In most of the parts that we run, we don't really run into issues, but we also are strategic about which parts we're running on there. But parts like those channels that we ran where you're gauging off of a bend, there's certainly potential for variability with that.
Jacob, you have any other?
Yeah, so kind of what you guys were mentioning a little bit earlier about how hard you run the system. Like if you're running the system 100% of the time as fast as it could possibly go, then any blip in that system is going to cause variability. Whereas if you dial it back just a little bit, that 90%, something that is going to work all the time, 100% of the time, that's when you're going to, really reduce that variability and get those consistent cuts that can easily be picked or sorted by a robot, where you don't have problems with, when you get to the press brake or something like that either.
What about, I know with lasers, especially if you're highly automating the skeleton, picking and placing parts out of skeletons, maybe in a lights out situation, even, which I know, Russ, you're not doing too much lights out, but some fabricators are, they're worried about tip upgrade or other things that cause the machine to stop. What type of systems, technologies in place to help fabricators kind of alleviate their concerns about what happens overnight when the machine's running and they're not there?
There are systems built into the laser to track how well the system is cutting. So like if it realizes that it is not cutting well at all, it can stop the system and be like, something's not right here. It can send alerts and things like that, and be like, there's something wrong. Someone needs to check this before we ruin an entire sheet of material.
Okay.
Which is nice, but it also stops the machine for your overnight production, but at least you're not wasting material.
Of course.
There's other things we're looking into. You mentioned vision systems, like that's going to be the next big key. Problem is those things are rather expensive. So, sometimes it's going to be easier and more effective to like try and learn the parts, figure out, if you have problem parts, seeing what you can do to alleviate those problems at the part level, rather than having to, invest a lot into just a whole bunch of sensors, instead of just, changing fundamentally what could be the problem.
Like any technology too, the optics and things like that, prices will come down eventually, and then the technology will be embraced a little bit more.
Oh, absolutely.
So we've recently invested in an entire training center with Bosch, Allen Bradley, Mitsubishi, and Siemens. So we've got the full modules. We bring customers in. We do like overtraining. You cannot, whether you're internal to your own people or to your customers. The more training is absolutely critical. So that's one thing that we've invested in, is this training. When customers visit us, they can't believe like an entire lab and a training center set
Yeah.
up. Especially for the OEMs, they've sent groups up to, a lot of people to do training. And the thing with like a tier 2, like George is gonna find, he's got people that already know our system and a champion within. So we try to train the champion, right? Every company has champions of certain equipment and train that champion so that they train internally. But I think having a training center internally is a really big asset for us anyway, so.
We've been seeing a lot more too. You were asking about new technologies that are available for that. There's a lot that, there's a couple companies in particular that are doing with AR. They're doing a lot of augmented reality training to help supplement the training and make it a little bit more. And I hate to say the word, but when you're talking about the younger generation and trying to engage people, you kind of got to make it sexy again. It's got to be cool.
The glasses on.
Lasers and AR and VR, those are all cool things, you know.
Oh, yeah.
Sitting there in front of an old greasy machine like we all used to do, not so cool anymore, you know. So I think that the training and the technology along those lines is coming along with the industry to, help develop that next generation workforce.
Do you find that too, Ross, with the building up these champions of technology implementation at your company helps integrate some of this?
Certainly, yeah. I mean, there's people that take to it quickly and easily, and then
They train with it, right?
and they start training others below them, and
Yeah.
people learn from each other pretty quickly.
So where do your automation ideas come from? Do they come from the floor? Do they come from you?
Everything, everywhere. I mean, it comes from the floor, comes from me, comes through Fab Tech and other shows like that. Resources like this, tuning in online, learning from other companies.
Also, a lot of them come from customers.
Yeah.
Your customers present you with problems, and that's probably our favorite thing to do is
Yeah.
tell us what's wrong. We'll see what we can do to fix it.
Yeah.
It's a lot of fun to do that.
Yeah, the customers know a lot, right? So,
Yeah.
Right.
yeah.
From our audience, automation is an umbrella term used for robotics. Anything from robotics to AI, right? So outside of robotics, what type of automation do you guys see helping our industry the most? And examples that are presented here is predictive maintenance. I'd be curious to hear from George and from Ross what you guys are doing with predictive maintenance. Sensors, software, controls. What's the automation technology that you're most excited about implementing moving forward? And George, I'll let you think about that one. I'm gonna put Ross back on the spot again.
Shoot, I was gonna see if George wanted to go.
Sure, I've got a couple of things.
All right, go ahead, George. There you go.
We have some software. Well, there's two things. One is indirect and one's more direct. Indirectly, what we've done is we've integrated all our presses and robots to a software where we set the standard, say it's 30 parts per minute or 60 parts per minute, and the actual press provides that data back to the software. And at the end of the day, well, it's live, actually, we can look at it as we speak. And at the end of the day, the group leaders get together and look at it and say, where's our biggest problems? And if they say it's press P63 or whatever the case may be, and it's this particular part, they focus on it. It could be a quality issue, it could be a labor issue, the guy who are picking and placing the parts, or it could be a maintenance issue with the press, or it could be a maintenance with the robot. So it allows them to dig deep into that quickly rather than waiting for someone to input all that data and then to get the report a week later. It's a great visual tool that our team jumped onto it right away. And the funny story is that when we did a beta test on it, we put the big screens on the wall, the flat screens on the wall, and they showed all the pieces of equipment and they were showing the uptime. And we got a 3.5% or 4% uptick in productivity alone, just because people realized they were seeing their data live, and that was one thing. And it actually drove product quality down, quality issues down as well, because they were jumping onto the problems right away and focusing on specific jobs. The other thing is that we put cameras on our robots. And if there was a failure on a particular day and a particular shift, we were able to go back and watch that robot do its thing and see where the actual error occurred or the quality issue occurred, which was really helpful. And then if the problem diminished or disappeared, then we would take that vision system or cameras and put it on a different piece of equipment to see while something was running, and we could see, we can actually visually see what the problem was. Because with robots, they just keep going, right? And you're not looking at it, but they do sometimes have errors. So those are two things that we did incorporate within our plant that helped a lot.
Awesome, thank you for sharing that. Ross, anything on your side?
I would just kind of reiterate a little bit of what George said. I think just data in general. I think between ERP systems, and then those communicating with your equipment. Ours, we currently don't communicate with our equipment. A lot of the data that we're tracking is manual. But I think down the road, that's something that we would be looking at, is trying to automate some of that data tracking, being able to utilize that. Like it's such often is what's not measured isn't improved. So when you're measuring and collecting data and utilizing it in the right way, you can improve.
And the quicker you can respond to that,
Right.
the better it is. So that's really where we see it too, is just having that real time feedback. It's gonna be key going forward.
Good. Terrific. Well, unless anybody else in our audience has any questions, I think we've covered the subject really well. George, thank you so much for being here with us today, and the rest of our panel. Really appreciate your participation, and of course, all of you that joined us online. Thank you so much for being here today. And I know Ross mentioned more than once FabTech, so we appreciate that. PMA and MetalForming are partners in FabTech, and you can see all of this technology and more, sensors, IoT, all the stuff that you mentioned, robots, at FabTech in Orlando in October. So Doug will be happy
That was not on purpose.
So before we go, and again, everybody, thanks for joining us today, our panel as well. I want to acknowledge our production team. We always make sure to do that. Our event coordinator, Allie Miller, our marketing director, Drew Gutierrez, our videographer extraordinaire, Christian Paprika, and Randy Kish, our amazing director producer. So thanks, team, for another great production. We'll see everybody in July for the start of our 3-part summer MetalForming Live series. The topics we'll be covering are end of line automation. We'll be talking about how new steels and high strength aluminum alloys impact press line equipment selection. And then our final MF Live event this summer will cover press brake selection and process optimization. So visit the website for details. Thanks again for joining us, and we'll see you all soon.